Okay, so today we're going to do 9-5 on hyperbolas. Okay, and the author defines a hyperbola. Looks like hyperbola, but you pronounce it hyperbola. Okay, a hyperbola is the set of all points in a plane. It's the set of all points in a plane. Use this backward epsilon, that's the Greek letter epsilon. That Greek letter stands for the words such that. Okay? Mathematicians are lazy. They're going to use shortcuts for, so it's the set of all points in a plane such that the absolute value of the difference of the distances from two fixed foci is a constant. And they actually show you a pretty good picture of that in the book. I'm not going to draw that in the notes. There are two main formulas if your hyperbola is at the center 0, 0. Okay, the first one is x squared over a squared minus y squared over b squared equals 1. Okay, that's one. Another one is y squared over a squared minus x squared over b squared equals 1. Now those two formulas look very similar to the ellipse. What's the difference? Yeah, the minus sign. If it's a plus sign in between, it's an ellipse equal to 1. If it's minus sign, okay. And I'm going to take you through on graphing a couple of these. We're not actually plotting a lot of points. We're only going to plot a few points and then just sketch it in. So on a graph, they will say graph x squared over 4 minus y squared over 9 equals 1. Okay, first you look at this first term, and on the, I just say look at that, it tells you it's on the x. You take the square root of the number below, and it's 2 and 2, or 2 and negative 2. So on the x, go out 2 and negative 2, and just plot a point. Okay, then look at this term that tells you on the y, take the square root of the bottom number, 3 and negative 3. So on the y, go up 3, go up 3 and down 3. Can you see that good enough? Okay. And then what I do next is I draw a little rectangle. So look up here for a minute. I'm going to make this a little bit bigger. I draw a little rectangle and dash it. This is not part of the graph. This is part of our guide. So I just take those points and draw the rectangle to include those points. Does that make sense? Okay, and then you draw what they call an asymptote, a guide, through the corners of that rectangle. So I'm going to go through the corners here. So I'm going to do, and you should, and it's just a like an asymptote. I'm a little crooked there, huh? This is pretty quick. Okay. It should go the same every time. It should go 2 to 3 because that's the way I'm just doing the sketch. I'm a little crooked on that one, I think. Should do a little bit better here. Okay. So you just, and I would use a ruler and just draw the asymptotes. Okay. Now, from what we looked at the double cone, you can see there's two parts of it. Well, how do you know? Is it going to be on the X or the Y? On the hyperbola, it's always the first term. So you're going to look at that first term and say, okay, it's on the X. So I'm going to go to this X point, and my hyperbola is going to approach, draw a smooth curve. It will approach the asymptotes. It should not touch it. It should get closer and closer to it. And then the other one, it does go right on top of the point at 2, at x equals 2 and x equals -2. And that's it. Okay? So that's not too bad for the sketch. We're not plotting a lot of points. We're just doing that much. The advantage is to do that rectangle and to do your asymptotes, and then remember that it's the first term determines am I on the X or the Y. Okay? So let's try another one. I need another graph. Hang on. Okay, so number 2, let's graph y squared over 36 divided by 36 minus x squared over 9 equals 1. Okay, so these are at the origin because it's y minus 0 squared, x minus 0 squared. So I'm going off the origin. This says go on the y, go up 6 and down 6. So I'd go up 6, plot a point, go down 6. Okay, and then this says on the x, take the square root of that bottom, so it'd be 3 to the right, 3 to the left. Take those 4 points and draw in your rectangle. Okay, and then draw your, and this would be better if I had a ruler, draw your asymptotes from corner to corner, okay, as best you can. And it should always go through your center point. So you basically have 3 points there for a line. Oop, a little crooked on that one, sorry. It'll be better. I need a built-in ruler. Okay, so once you get your asymptotes, have you done asymptotes before? No. Oh, okay. Maybe we need to write down what that word is. It's called an asymptote. An asymptote is a guideline for your graph. Okay, what we do in Algebra 2, they are all linear lines. But when you get up into calc, you'll have asymptotes that are curved. Okay, so try saying that word, asymptotes. Yeah, asymptotes. Okay. Okay. So once you get your asymptotes, and none of those should be solid. The box should be dashed. The asymptotes are dashed. Anything solid on your graph is part of your answer. So now the first term on a hyperbola determines where the graph's going to be at. So you go on the y, up and down on this one, and it goes right on top of that point on the y, and then you just draw your curve as best you can. Put an arrow on both ends because it's going to continue. Go down here to -6. Okay, and that's your asymptote. Okay. Okay, on the. Okay, good with that? Okay, on the ellipse, we had a formula for the c squared. And this one you have a formula. It's c squared equals the a squared plus the b squared. Okay, and now the author goes through what's the a and what's the b. Okay, the distance from the center to the vertex is A. Okay, and the distance from the center to the focus is C. And I'll show you that in a minute. The transverse axis is a segment of length 2A, because remember A went from the center to the vertex, so the whole thing is going to be 2A, and that's whose endpoints are the vertices. That's what they call the transverse axis, and it's 2A. The conjugate axis is a segment of length 2B that is perpendicular to the transverse axis. The conjugate axis is a segment of length 2B that is perpendicular to the transverse axis. Okay, so go back up to let's go back up to the first picture. Okay, and let's label, I'll bring it back down. Label the A. Where would the A be? This would be considered the vertex. So isn't this our A? And this would be A. So this is our transverse axis, would be 2A. So label this. This is actually our, I need to write that smaller. This would be the A, would be 2, and the B, okay? The transverse axis has to have the vertex on it. This is the vertex, where the hyperbola is, okay? So that's your 2A and your 2B. On this one, from 0 to, 6, this is our A, and this would be A, so the whole thing would be 12, right? And then this would be the B and the B, okay? And then if you need to get the C for the focus, and the foci are going to be, and I'm just approximating it, the foci are going to be on what I call the inside, so the foci are going to be somewhere in here, okay? I'm not figuring it exact. The foci are going to be somewhere here and somewhere here, okay? And to figure out what those are, you got to use this formula. And it's different than wasn't the one for the ellipse a minus sign? Wasn't it? Wasn't this C squared formula, wasn't it a minus sign on an ellipse? Yeah. Okay. Okay, now, that's if you're at the origin, 0, 0. What if you're off? Okay, if you're off the origin, there's two new formulas. Let's go. Those two formulas are x minus h quantity squared over a squared plus, sorry, I'm so used to the ellipse. Change that to a minus. Minus the quantity y minus k quantity squared over b squared equals 1. So that's one formula. If you're off center, what do you guess the center point is? It's still hk. So you graph your center, and then you would do the square root of this, go left and right, okay? Square root of this, go up and down. Okay, the other one's going to be y minus k, quantity squared over a squared, minus x minus h, quantity squared over b squared, equals 1. On the 4 formulas that I've given you, where's the a squared? It's always first on a hyperbola. Is it always the bigger number? Not necessarily. Okay. Is it always under the x squared? No. Okay. So, okay. Okay, now, instead of writing out the whole formula set, okay, I decided on the hyperbola I'm going to give you a formula sheet, just like you had on the test yesterday, and you can put it in your notebook. Okay. The formulas appear on 624 and 625, and anybody that's gone needs to pick up that formula sheet or refer to those pages in your book. Okay. Okay. Any questions?